Another important concept we have to look at when talking about integrals and integration is the average value of a function. Right now, we're going to be only looking at functions, so what we're really going to be finding is our average y value. As we start moving forward into more application type problems, we're often going to be talking about our average amount of accumulation. So the average value theorem basically tells us is that as long as our function is integrable and as long as we're on a closed interval, the average value is going to be the distance that we've traveled, because if we start at, say, 2 and end at 5, notice that b minus a is going to be 5 minus 2, it's going to be 3. It's going to be a total distance of 3. Or as we move into application problems, it's often going to be the total amount of time that's gone by. And then we're just going to go ahead and integrate our function using the fundamental theorem of calculus. So really we're just kind of taking what we've already been doing and then adding this 1 over b minus a, and then like I said, that's going to give us our average value. So let's look at 2 examples. So in the first example, I'm finding the average of this function here, 2 over x squared, and I'm going from 1 to 4. So all I'm going to do is 1 over 4 minus 1 times the integral from 1 to 4 of my function. I'm going to anticipate that I'm not going to be able to integrate with that division bar, so I'm going to change this to 2x to the negative 2 dx. And I'm going to end up with 1/3 times 2 times x to the negative 2 is going to become 2 over negative 2 plus 1, so 2 over negative 1, so negative 2 x to the negative 1, and I'm going to integrate from 1 to 4. So when I'm integrating, I'm going to rewrite this as negative 2 over x, and I'm going to get 1/3 times negative 2 over 4 minus negative 2 over 1. Doing my math and calculating that gives me 1/3 times, that's going to give me 3 over 2. And 1/3 times 3 over 2, my 3's cancel out, leaving me with 1/2 for my average y value over this for this function over the interval from 1 to 4. Looking at one more example, I'm going to do the same thing. Now my interval goes from negative 1 to 4. So according to my formula, I'm going to have 1 over b minus a, so 4 minus a negative 1 times the integral from negative 1 to 4 of 3x squared minus 2x. So that gives me 1/5 times the integral from negative 1 to 4. And actually, I'm going to just go ahead and integrate this rather than rewrite my integral. So 1/5 times 2 plus 1 is 3, so I'm going to have 3 over 3, which is going to be x cubed, minus 2 over 2 times x squared. And I'm integrating from negative 1 to 4, which is going to give me 1/5 times 4 cubed. And let's see, 4 cubed is 64, minus 4 squared, minus negative 1 cubed, minus negative 1 squared. Working that out, I'm going to get 50 inside of my brackets. And 1/5 times 50 is going to give me 10. So that will be my average y value for the function 3x squared minus 2x on the interval from negative 1 to 4. That's all the average value is. Just making sure not to forget to have this piece out front. I know I've been guilty before of, as I'm going through my work and I'm concentrating on doing my integration, that I start to forget to bring this along. So do be careful of that.